So sorry for the interruption. Thinking my phone's on silent and do not disturb, but somehow people keep calling and cutting me off. Enough about that. All right, I think we ended up right here where we were taking the cube root and we did not need the absolute value. Okay, with an odd root, we don't need it. So at this point, we just have one answer. So no matter what value you put in for x, you're just going to get one number back as an answer. It might be positive or negative, doesn't matter. But you only get one output, one y value, one answer for any x you put in. So the answer is yes, that this problem y cubed would be a function. So had this been y to the fifth, the answer would be yes. Had this been y to the seventh, the answer would be yes, this is a function. Contrast that over here. Had this equation had y to the fourth instead of y squared, where 4 is even, the answer would still be no. All right, one last one down here. Hopefully we'll make it through. All right, look at the difference between 17 and 18. We've already solved 17. 17 was y equals the absolute value of 4 minus x. Now, think about the graphing calculator. You could certainly enter this equation into the calculator because this equation is already solved for y. Not y squared, not absolute value y, but just y. This is calculator ready. So if it's calculator ready, then that tells you, hey, that must be a function because that is a function grapher. That calculator will not graph non-functions unless you go to the draw menu, which is a different thing. All right, look at 18. So 18 is not solved for y, but it's almost solved for y. Now let me take y out between the absolute value bars, but when I do that mathematically, remember, what that means is I have to adjust and put plus minus in front of the right side of the equation. And don't forget, because you have a couple of terms here, to put 4 minus x in parentheses. Okay, at this point, if you plug in 0 for x, then you're going to get 4 in the parentheses, and then applying the plus minus means that when you plug in 0, you're getting two different answers back out. This is not a function. So this answer is no. If you think about what this graph looks like, it's actually a sideways opening absolute value function. Instead of opening down like this one, I believe this function is going to look something like that. Function, listen to me. Okay, I believe this graph is going to look something like this. And if you do the toothpick test, I mean the vertical line test, okay, it fails. This is not a function. Not when this absolute value graph opens up on one of its sides. So this is not a function. This produces a graph that's a relation, but not a function. Thank you for hanging in there with all these videos.